All right, let me. We'll wait for a couple of minutes to let people get logged in, but can everybody hear me? What's going on?
Yes, we can hear you.
Oh, did you get it? Okay, great. Keep it until the end of the semester. That's what I got. So we don't have to keep going back and forth about it. Just hold on to it, and then when it's time for when the semester ends, I'll give it back. Or if you need it, you can keep it. It's fine. Yeah, no problem. I promise. It was a calculated move. So just hold on to it. Yeah, that way you don't have to worry about recording. You can record straight to that, put it on Google Drive, and then I'll get it. You can send me the link, and I can upload the recordings.
Okay.
Yeah,
All right,
yeah, we're good.
All right, just making sure.
Okay, all right. Yes. Hold up. Did I send a link out yesterday? I mean Monday. Look at that announcement in Blackboard and use that link.
Capital DVJ, DV as in violin, and then J, 2, and then capital U.
Yeah, you should, if you log in with the link that I sent, you won't need a password. It'll just go bring you straight to the meeting. All right, is everybody who in here in? Good, all right. Yeah, if you go back to Blackboard or to your email and find the link that I sent out on Monday, you won't need a password or anything. You just be able to log right in. All right. So what we're gonna do first is I'm gonna have everybody go ahead and pin Albert's iPad. That's the name of the iPad that's showing up. Go ahead and pin that so you don't have to search for it when we putting the notes up or whenever I'm moving the camera around. All right, you can go ahead and pin that real quick, and I'm gonna pin it. Let me go the other way.
For my temperature, it's just like 1 to 10.
Put it on about 7, because you want the water to be hot but not boiling. All right. So what I'm going to do now is just kind of give an overview of what we're going to do today. Let me turn this video off right quick. And then I'm going to share my screen. All right. So I'm gonna walk us through the actual experiment, and then after that, we're gonna jump right in and get started. So let me get a page of notes open. All right, can everybody see my screen? Hopefully. So it's take the gloves off and stick it to the screen. So today we're doing again synthesis of aspirin. I'm going to learn a couple of techniques. The first technique we're going to learn is how to actually set up a synthesis. Right, we're going to go through how to set the synthesis up, and then we're going to learn how to use a water bath, which is not overly complicated, but it's still a technique. We're also going to learn about vacuum filtration. Sorry about that. The rain is affecting my handwriting. Not really. It's bad. It's just bad anyway. We're going to learn vacuum filtration, how to set up a synthesis, how to use a water bath, and also we're going to learn a couple of different types of reactions. Namely, acylation reaction. All right, so that's what aspirin synthesis is. It's an acylation. So let me show you if you have the data sheet, you see the reaction up top. I'm not going to go through the mechanism because I've already sent that out. So you can go back and look at that, but we're going to talk about what's going to happen today. So this is salicylic acid. You can see it has a couple of functional groups on it that we've studied in part 1, right? It's got an alcohol, it's got a carboxylic acid, and it has an aromatic group. The aromatic is not going to take place. It's not going to participate in any reaction. It's too stable. But the carboxylic acid, it doesn't react as fast as the alcohol, right? Because the electrons on that acid oxygen, the hydroxyl group, are tied up in resonance. So it's the alcohol oxygen that's going to do the reaction. So we're going to take that and react it with acetic anhydride, which is a type of ester. Right, so this is an ester. But the group that we're going to take off the ester is right here. Right, it's this group right here, not the oxygen, just that group that I have highlighted in pink. And we call that an acyl group. So that's why the reaction itself is called an acylation, because we're going to take that acyl group. We're going to do this in the presence of sulfuric acid as a catalyst. We're going to do it in the presence of sulfuric acid. Right, that's just a catalytic amount. So on the data sheet, you can just put 6 drops or 8 drops or however much we added. But it's only a catalytic amount. It's not a reactant, it's a catalyst. All right, so add sulfuric acid. We're going to do this, and we're doing it neat. That means there's no solvent. Right, so the acetic anhydride is a liquid. Salicylic acid is a solid. And here's the thing about this reaction, again, it's neat. So we're going to add the salicylic acid first to an Erlenmeyer flask. And then we're going to take that salicylic acid in the Erlenmeyer flask and add the acetic anhydride directly to it. All right. And then once we do that, we're going to heat it until it goes clear. Everything dissolves. That's how you know the reaction is done. When all of the salicylic acid is gone, and it's clear, it's a clear solution. It might be a little pale yellow. That's how you know the reaction is done. So aspirin on this side of it, on the other side of the reaction arrow is going to look like this, where we have acylated the oxygen. Again, this is called an acylation reaction because we added that acyl group to oxygen. And then what's left over is going to be, and you're going to smell this when you get ready to do your filtration, it's going to be acetic acid. It's going to smell like vinegar. Right, this is one of your side products. That's one of the reasons why we have to purify it, right? We want to get rid of the acetic acid that's left over and any unreacted acetic anhydride. And I didn't write the name up here, but I'll write it here. Different color. Acetic anhydride, and this is acid. All right. So once we run the reaction, again, you're going to heat this on a water bath until it goes clear. Once it goes clear, you're going to heat for an additional 5 minutes, and after that, you'll take it off. We're going to add cold water to it, 40 milliliters, and then we're going to wait, put it on the ice bath, and then filter it. All right. If during the course of the reaction, your synthesis, your vessel, and the components in the vessel, if they go solid, right, that means that your vessel is not hot enough. So what you'll have to do is increase the temperature in order to get that salicylic acid to dissolve and react. Right? If it goes solid, it's fixable. It's not a problem. All you have to do is turn the temperature up a little bit. You can actually turn yours down some if you like.
Yeah, so I just turned it down to like 3 or
Yeah, you can
4.
turn it down. Because as long as the water is hot, then we're in good shape. All right, so we're gonna run this reaction. I'm gonna move the camera around so you'll be able to follow, those of you who are streaming. And I'll post this little page of notes in the video. I'll post that to Blackboard later on this afternoon. I'm gonna turn over. All right, are there any questions about the reaction itself? Again, we're not going through the mechanism because I already sent that out. You should be able to go back and look at that video and see the arrow pushing, which we've already done. Yeah, just turn it down. And once it stops boiling, you can put it back up there. Okay. But it's not gonna hurt anything if it's boiling. It's fine. It's water. Yeah. All right. Are there any questions about anything that we've talked about? And can everybody hear me okay? All right.
Yeah, we can hear you.
Okay,
Yes,
great.
sir.
Get my iPad back. Okay. All right. So what we're gonna do is let me stop the video on my other. Okay. So what we're gonna do is a couple of things. We're gonna have each person come up and weigh out their own salicylic acid. All right. And again, for those of you who are watching, on your data sheet where it says required amount, we're going to cut that number in half for both acetic anhydride and salicylic acid. So for acetic anhydride, it's going to be, instead of 14 milliliters that the procedure calls for, it's going to be 7. And for salicylic acid, it's going to be 6.9 instead of 13.8 grams. You also need to look up the information, the molecular weight, boiling point, all the physical properties, the density. You can look that up during the course of the lab, so you'll be able to fill those columns in on that data sheet if you haven't done it already. All right, so let me move. I gotta keep my iPad plugged in. This chart is going down. I'm gonna move the camera over to here to the balance. All right, and we're gonna take, what's your name? Hey, come on, you can go first. We're gonna weigh out. Let's bring your early mark flash. No, not that. The early one, the little 125. No, not that. That's the vacuum flash. We're going to use, yeah, that's a vacuum flash. This right here. So go ahead and take a piece of wax paper, put it on the balance. Everybody knows when you use the balance, first thing you want to do is zero it out. So you put your wax paper on there, zero it out, and then once you zero it, you can start adding the salicylic acid. And there's a scoopula up here already, so I'll put it. And then, use the silver super over there. 6.9 grams. Zero it again, and then normally the scale is, the balance is very sensitive, and just the air blowing over it will make it jump. So normally we do this with the door closed, but I'm gonna leave it open. That's fine. Go ahead and start it. All right. So you want to get as close to 6.9 as possible. That's why there are two columns. One says required and one says actual. So you want to get as close to 6.9. That's okay. Go ahead. This salicylic acid is very fluffy, so be liberal with it. You know, as far as adding, because otherwise we're gonna be here till Christmas break. Yeah, there you go. You good? Don't be scared. Just do what you gotta do. All right. And while she's doing that, again, we're gonna add every person in here is gonna have early March flash 125, and you're gonna add salicylic acid to it. So what I'm gonna do for those of you who are streaming is when I put the values in the chat, you pick which one you want to use, and you got to stick with that because I'm gonna label these samples at the end. And once I label them, if you use, let's say for instance, Chloe's sample, then that means that next week when we get ready to do the recrystallization, that's the sample that you're gonna stick with, and you will keep those values consistent. Um, 6.6. Let's see how close you. All right, how much was that? It doesn't have to be exact. If it's over, it's fine. 6.98. $6.97. So, and tell me your name again, Haley.
It's still going down.
Stop.
Yeah.
Yeah, just turn it off. Because that bath is by the time you get ready to weigh your stuff out and add everything, it'll still be hot enough to do the reaction.
It's down to 6.5.
Yeah, we'll do 6.51. So Haley's sample is 6.51 grams of salicylic acid. So you're gonna take that off the balance and transfer it to here. Hold the paper off and then put it right into the flask. Is it Haley? I messed that all up. 6.51 grams.
Dr. Russell, what are the measurements for the required amounts?
So the required is 6.9 for salicylic acid and 7 milliliters, 6.9 grams for salicylic acid and 7 milliliters for acetic anhydride.
Okay, thank you.
Yeah, no problem. All right. So once you're done adding, then we'll just go by row. So Eli, you'll come next. And then Chloe and Stacy. And y'all only working on one hot plate back there, right? All right. So it doesn't, one of y'all can just come and do your all right. So again, we're gonna take 6.9 grams, weigh it out, put it into the early mark flask, and then after everybody adds their stuff, we're gonna we'll add the acetic anhydride. And I'm gonna actually come around and add that. Go ahead, you can bring it. Bring that with you. And there's a scoopula, and if we run out of salicylic acid, I got more over here. All right. Use the silver. It's easier to get it out of that big tub with that. All right. Anybody have any questions while we wait?
Are we supposed to choose like which sample we want to use, or are we like assigned to a specific person?
No, you choose. Once you pick a number, then that's the person that you're gonna ride. That's the information that you're gonna ride with from here on out. Because the next time it's gonna be a different group of people, but it'll be the same samples.
Okay, thank you.
6.91. So Eli. Is it 6.91? All right, I'll put 9.2. All right. So just take that, fold it over, transfer it into the early mire. And then we'll let the next person come and weigh their stuff out. And let me get the sulfuric acid. All right. So one of the things about this experiment, again, if your water valve is not hot enough, then the reaction is going to slow down and it's going to act. Yes, this happened to somebody yesterday. The reaction is going to solidify. So it's really important to keep that water valve hot, as hot as possible, without necessarily boiling. All right. Just tap with your there you go. Now those techniques we don't learn in lab, but y'all don't. Never mind. Y'all didn't hear that from me. I was talking about BC powders, by the way. See how you immediately went to something criminal. I was talking about goody powders, man. I'm joking. Come on. All right. You know, it's the third person now, so you got goody powder. Yeah. Pharmacology. It's catalytic. The 8 drop that have no, because it's not a reactant, so we know it's just a catalyst. So everybody who's streaming the sulfuric acid is a catalyst. It's not a reactant. So we don't care about the number of moles and all that stuff because it's present in such a small amount that it can't be the limiting reagent. So if it's a catalyst, it's not going to get consumed. It's just going to get regenerated at the end. Try to get closer if you want. All right, we can roll with that. So for Chloe's sample is 6.96 grams. All right. So just fold that over and boom. Wow.
Still don't think of
There you
it.
go, TV. Not like no TV. You're not gonna make a mess, just fold it and give it a little tap. You'll be good. We made a mess yesterday. Well, I did. I'll take the blame. Yeah, just leave it. I'll put all that over. All right. So we got two more people that have to weigh out salicylic acid. And then we're gonna add the acetic anhydride, and then we're gonna add the sulfuric acid. In the procedure, it calls for you when you add the sulfuric acid to use an ice bath, but we don't have to do that. It's such a small amount, and the reaction itself has already been cut in half, that it's okay to not do that step on an ice bath. The purpose of the ice bath is because the sulfuric acid step is exothermic. So if we were doing it on a bigger scale, it would be a bigger problem. But because it's on such a small scale, we're not going to worry about that part. About the sulfuric acid? Yeah, there's a step before you add the sulfuric acid that tells you to use an ice bath, but we're not going to do that because it's the amount is already small enough. So we're not gonna have to worry about it being so exothermic that it overheats or anything like that. About 10 grams, I think it's kind of short. All right, leave it. Just leave it. Yeah, you can't. Don't put it back in the thing because then that'll contaminate the stuff that's still in there. So take that, slide it, hold it up, and then just transfer it right to the early part. All right. So Stacy had 7.4 grams of salicylic acid. And then we got one more group, and we're gonna proceed. Once we get the reactions going, it's not gonna take long. So you get that's dirty, that's clean. On the left is clean. Yeah, just use a piece of that, and then sit that on the balance. No. Take on the balance first. On the plate, underneath. And on the chair or zero, left foot. Then once zero comes up, then you'll add the salicylic acid. Go ahead and get some on the spatula first. There's a spatula down in there inside the drawer. So get some on there first, and then zero it, and then add. Catch it before it starts fluctuating. Get the zero button. Get zero, put that on. There you go. All right. Your name is that Austin?
Yes, sir.
Keep that. You need 6.9 grams. Right now you're at 394 milligrams. So keep adding.
For the salicylic acid count out there.
How'd you calculate? 7 grams divided by the molecular weight? Yeah.
For the acetic anhydride, you would use those here,
Yeah, that's why you have to find the density.
Okay.
So use the density to convert 7 milliliters into grams, and then grams to moles with the molecular weight. Exactly right. Would you go over?
Yeah.
7.9. We'll ride with it. We'll increase the amount of acetic anhydride on it. So just take that, fold it in half, and then just transfer to your flask.
The Would we use the actual methadone?
Yes.
Okay, that's what I.
So we have the required is 6.9, and then your actual was 6.92. Yeah. So that's what you'll use to calculate the moles.
Okay.
Yes. Did it, hopefully, I was talking to Eli, but I want everybody on here to hear the same thing. When you calculate moles, you need to use the actual amount. So let's say somebody chose to use Haley's amount, which was 6.51. When you're trying to find out how many moles that is, use that. Don't use the required amount of 6.9. All right. So now we got everybody has salicylic acid. So what I'm gonna do is go around and add the acetic anhydride. All right, so hopefully you guys can see. I'm gonna keep the camera trained up here, so I don't have to keep walking around with it. But you might want to make sure your water valve is a little high.
Yeah, I turned it up a little bit.
Yeah, all right. So this is acetic anhydride. For those of you who didn't look up the density, I guess I can give it to you now. My eyes are not as good as they used to be. Let me find it first. The density is 1.08 grams per milliliter for acetic anhydride. 1.08 grams per milliliter. All right, and you need that because this is a liquid, and you need grams and not milliliters in order to find moles. Right? 1.08 grams per milliliter. All right, so let me have your Erlenmeyer. You see it right there. Let me make sure it's on camera. Slide it back a little bit towards you. Right there, perfect. All right, so I'm going to use a syringe. I had some needles, but they were the gauge was too thin, so it took forever to fill up the syringe. I'm just going to take a syringe, and we're going to add 7 mils to each person. The syringe is a 6 milliliter syringe, so I'm going to have to add twice. So I'll add 6. And then I'm going to add another 1. This is why I need a needle, so I can get that air bubble already. All right. And then at the same time, I'm going to add in sulfuric acid. That's going to push the reaction. It's going to make it go faster. I'm going to add 6 drops of sulfuric acid each reaction mixture. Sulfuric acid is the reason you do not wear sandals to lab. If this stuff gets on you, it's a wrap. You can sit that in there. You can turn that down some too.
Okay.
All right. Okay. Same thing over here with Eli. No. Sit the whole flask out. Oh, please don't pour it. Boy, earth, geez. Do it. I'm joking. Don't get offended. Don't call the D.
He was trying to embarrass me. Doesn't like me as possible.
It's okay if it don't.
Yeah, it's not gonna sit at the bottom. That's fine. Seven, 6 drops of sulfuric acid. All right. So you want to swirl that, just sit it in there. And you can put that back on the hot plate. Just put it on like 2. Yeah. Because it's got to be hot in order for that reaction to take place. You got to heat it to the point where all the salicylic acid goes into solution. All right. You can twirl it, turn it, yep.
How do you get that?
Don't worry about it. The heat, the vapors will get it. Yeah. Don't turn. That's too close to the. It's too close to the edge. We'll do it. Try to get it. sit it down in it. Let it sit. Let it sit. Swirl it periodically. But just leave it in there for this. Every time you take it out, it's gonna cool off. You want it to stay at a constant temperature, so the reaction can go as planned. Fire goes down. Down on the phone. Right. Right. Do it. We have one, but that's a track in the hall. How about that? Yeah. All right. All right, there you go. Put it down in the water. Every now and then, you can see that. See right away. That something happens. Hold on, see that on camera. It's going to get clearer. But you want it all the way through. You want that done, want it all the way through.
Are you going to the poultry farm?
I probably would.
You want it all clear yet?
Mine,
Mine's still.
All right.
mine,
Live.
well,
Go ahead and pour it a little bit.
it looks clear to me. I hope it is.
Yeah. See that? That's going, that's almost done. Once it goes clear, you can set a timer for 5 minutes and you're gonna, now yours is too cold. That's the problem. Remember I said it was solidified, it wasn't hot enough?
That's what it's doing. It got fine.
Yeah, that's okay. When they heat, when that temperature goes back up in that water bath, it'll take care of that. Yeah. Once it goes clear. Yeah. So once you set the timer for 5 minutes, after that time is up, you're gonna take it out, put it on the bench top. Once your reaction goes clear, 5 minutes extra heating, and then sit it on the bench top. So what we're gonna do, the next phase of that, after the reaction is done, and the 5 minutes are over, we're gonna put it on the bench top, and we're gonna add some cold distilled water to it, 40 milliliters. So let me get, you got a graduated cylinder. Did y'all get one in the back? Grab a graduated cylinder, and then the distilled water is right there. Add 40, in the jug, yep. Add 40 mils and come and sit that down in the cooler. Got some ice right here. All right. So we need that distilled water to be cold. All right. So when we add it to the reaction mixture, it's gonna cause the aspirin to precipitate out. So we need that distilled water to be cold. So 40 mils of distilled water. And then we're gonna add it after the reaction mixture cools down to room temperature. It's starting to go back liquid. All right. Well, just keep. Yeah. What did you put it on? Oh my gosh. Hold on. All right, hers is done, so let's switch out. Yours is done. So let's take that. You got the plate for hell. That's what it is. I'm gonna sit it down here.
We got the E word, but I think it just stays.
It doesn't, yeah, it's probably, that dial is probably broken. I need to get rid of that hot plate. Or save it for, never mind. All right, I'm gonna step out for 1 second because I need to grab a couple more graduated cylinders, so just hold tight. And if you have a question, what's Austin, 7.9. If you have a question, you could just put it in the chat and I'll see it when I get back. Give me 1 second.
So what's a liquefied? We take it out. Oh, wait.
Anybody need a graduated cylinder? Need a flat, not a cylinder. Do you need one? Hayden? Or you got one? All right, good. All right. So another aspect of the lab that we learned is vacuum filtration. So what we're gonna do is take a vacuum flask like this, and we're gonna fit it with a Buchner funnel. Let me grab one right quick. Wilbur T was here.
Do I need to clean it up?
All right. So here's the setup for the vacuum filtration. I have a vacuum flask, which has a little aspirator nipple on the side. I have a Buchner funnel, which I'm going to use, not a glass funnel. And then a filter adapter, which is going to help the vacuum, going to help maintain vacuum inside the vacuum flask. So sometimes it'll fit into the hole. This one happens to fit. So I have it set like this. I'll put my funnel on top like that. And then I'm going to connect a rubber hose here to the aspirator on the sink. All right. And that's going to help me when I get ready for the filtration step. It's going to help me to pull off as much liquid as possible from that aspirin sample. All right. I think you're about ready, Eli.
You start a timer?
Sit it on the bench top first. Down on the top. And then we're gonna add water. All right, so at the end, let me see yours, Haley, right quick. At the end of the reaction, it should look like this. Pale yellow to clear. The only reason it might be pale yellow is because of maybe some impurities in the salicylic acid or in the acetic anhydride, but we're going to take care of that when we do the purification. All right. So once it goes like this is ready now. I'm gonna use yours. You already got your water cold. Nope. So give me that. I'm gonna chill this and then I'm gonna spill somebody else. All right. So what we're gonna do with this one is we're gonna add 40 milliliters of cold distilled water. And you're gonna see an instant change once I add the water. You're gonna see it go cloudy. That's a good thing. Right? The reason it's going cloudy is because aspirin itself is not soluble in water. So you add the water to precipitate out your aspirin. All right, now sometimes some leftover salicylic acid may be stuck in there. That's why we have to do what's called recrystallization, which would be the next time we meet. But you can see immediately that it's already starting to crystallize. So Haley, take your hot water, dump it out. You can see some crystals starting to form along the sides already. All right, so take your hot water, dump it out, and we're gonna turn that vessel into an ice bath. So everybody who's done with your water bath, dump it out and fill it up, not fill it up. Put it about halfway with ice. All right, we're gonna turn that into an ice bath, and then we're gonna sit the aspirin in the ice bath and let it crystallize. You can see this is already crystallized. That's quite a bit. It's gonna be a good year. All right. Anybody have any questions?
I have a question.
Go ahead.
I just want to clarify which document we're supposed to be filling out, because I know that there's a PDF and then there's a Word document too, and they kind of look similar.
Yeah, I would use the Word document because you can type right into it.
Okay, thank you.
And then just save it. And then the next time we come back, open that same document up, or if you're in person, bring it with you. And we're gonna fill it in, keep filling it in until we're done.
Okay. I just see that the PDF has sulfuric acid on the table and the Word document doesn't.
Yeah, well, I'm trying to remember, I updated, does the Word document have at the end of it, test for iron chloride, FeCl3, pH test?
Yes.
Yeah, use that one.
Okay, thank you.
Yep. All right, I need to get some too. Shall return. How bad?
Yes. But I kind of feel it more because it was like messy. It's still hot.
Has anybody not done the water addition yet? Yeah, we scoop it out. Want it to be a slurry anyway, so. All right, that's good.
So after 5 minutes is when we add that water.
Well, you can add it now. It should be close to room temperature. If you feel the bench tops, you can feel that they're cold. That's on purpose. The material is designed to transfer heat rapidly. So you sit something hot on it and it'll chill fast because that's what the material is made for. All right. So Haley, you about ready?
Are you supposed to be timing it? Were we supposed to be timing it? The amount
No.
that's-
Pour it straight into it.
Yeah, pour it in. And the thing about it, again, with the ice bath, once you sit the aspirin down into the ice bath, if it's really liquidy, then you let it sit. Once it starts to solidify, you can take it out because the point is to get as many crystals out as possible. And the only way to do that is to let it sit long enough for your aspirin to crystallize. You can put some water in there, Eli. It'll make it much easier. Here you go. Get that. You always want your ice bath to be more like a slurry. All right. So we're gonna get one of these filtrations set up. You can put some water in there. Just run it from the tap into the valve now, not the flask. All right. We're gonna get the filtration set up on Haley's side. Does everybody have a buchner funnel? If it doesn't fit, you can turn it over. Yep. That's that Carver. That's the Carver way. Make a way. If you don't have a buchner funnel, let me know, because I can go and grab a couple. Yeah, all right. So this is, give that to one of them, because you're gonna use this. Do you have one, Eli? One of these? All right, let me go grab a couple of buchner funnels, and then we'll get the filtration set up.
I don't know. Oh, it goes like, I guess, yeah, and then the other thing. I was like,
Okay, like that.
I was like that. Is there a requirement for the acidic anhydride?
Is there a what?
The required amount of
That is the 6.9 grams, 7 milliliters.
for the anhydride,
7
for the required?
milliliters. And then that was also the actual as well.
Yeah, you can let Eli have your vacuum flask, and we're gonna use this setup. All right, the last part of the filtration. Actually, you know what, Eli? Swap with Stacy. Give him that phone. Swap with Eli, Stacy, since you got a smaller vacuum flask. Yeah, there you go. And then you can take this vacuum flask. All right, so with the vacuum filtration setup, again, we're gonna have to use, we got a buchner funnel set up with a filter adapter and a vacuum flask. And then we're gonna sit a piece of filter paper down in here. Hopefully you can see that. Right? Normally, we use the high dollar filters, but today we use good old fashioned coffee filters. They work just fine. Been using them for 16 years. And they're cheap. So we're gonna get this set up, and I'm gonna bring the camera around so you can see the setup. Everybody also should have a piece of rubber hose, rubber tubing, so take that. And then you already got one set up. So all you gotta do is stick that on to your vacuum flask. I would take the part first before I try to put it on. All right, if it doesn't go on, you can wet the aspirator. Put no water on it, it'll slide right off. Might take some mad power, a little elbow grease, but it will go. All right, and we're gonna set up the one on this side so it can be visible. Can you pull up Zoom? It's still on. I don't make sure the camera is showing. All right. Also, one other thing, if you need to move your crystals around, that's fine. You can use a spatula for that, which I need to go grab. I didn't think about that. But if your crystals are stuck, you're gonna use a spatula to dislodge them. And then the second thing you're gonna do is rinse your flask. So keep that graduated cylinder because you're gonna need 40 more milliliters of water. It does not have to be cold. It can be room temperature. So we're gonna set this up here. And it on right quick. Yeah. Did everybody else get a coffee filter, get a filter? Pass that back, all the way back. My bad. All right, pull that on through there. All right. So you want to put that on the appendage. Yep. It's going on. You can slide the flask over too. So you know, there you go. Give yourself some more slack. All right. Once we get to that part right there. Yeah, smart move. I got you. Nope. There you go. It doesn't have to go on all the way. So what the vacuum hose connected to the aspirator is going to do, let me show you the aspirator part. I just use this one over here. I use this piece right here. When I turn the water on, it's going to pull backwards. So the water is going that way, and it's going to cause a vacuum in the flask. So that's why we call it vacuum filtration. So we're going to do, that's good, baby. Keep on the floor. Just like me. I was like, one more turn, and then boom. All right, so we're gonna do that, and we need to get your filter, and then we're gonna be able to add that. So take this piece of filter paper, fit it into that funnel. Just sit it down in there, yup. And you can actually pour a little bit of a liquid on there to seat it. So take a little liquid out of your flask with your aspirin in it. If it's got any liquid left, you can drop it. You can put a couple drops in there to seat it. And then all y'all need spatula. So 1 second. Go ahead, if you haven't already, get some more distilled water, because you're gonna have to rinse that flask out. It's not gonna sit. You can take it apart though. Okay. This is to get those crystals loosened up. when
You
get
said
ready.
tap water?
No. Distilled water. Never use tap water. Yeah. Never use tap water. That's a death sentence for your yeah, water. It's all right, but you just wash those crystals with that back. Let me see what it looks like. Is it solid all the way through? white. Good. These look better than the one that. But it's a school there. Yep. Oh, you could turn on your filters, turn the water on. And then take the 40 mils that you have and use that to rinse the flash out. What's left in there, gonna use that water that's in the graduated. Right? Not yet. Yeah, break it up first, and then filter, walk on with the hand on the filter, and use the water in the filter to rinse. Get the residue out. Yeah, go right ahead. Let me move the camera. Hold on. Don't pull it. Oh, the vacuum cloth. All right, go ahead. If you're streaming, you're gonna see the water that's in there come through. That's what you want. You have to see that, right? That's the whole purpose of running a vacuum. Or you could try it a little bit fast. It's not gonna be completely dry. All right, then we'll be if you just get gravity filtration. Take your water. You already added it? Okay, yeah, add that back to here. Get all that out of there. Everything out. You want everything as much as possible to be out of that flash. So add some of that water, swirl it around with the residue, and dump it right back right onto the filter. All right. Just swirl it. That's fine to just swirl it now. Yeah, and just pour it right onto the filter. There you go. Yeah, that's good. Good, Stacey? Yeah, it'll come. What you can do, so in the case of something like this, filter adapter, that fit all the way down into it. Things happen, my. All right, any questions from the document? You mean if you're talking about the data sheet, it's already on Blackboard. It's in the it's in the assignments folder on Blackboard. It's not gonna dissolve. If you want it to be a suspension,
There's like a big chunk.
it's not gonna dissolve. Just drop it. If you need to add more water, you can. You scared to turn it over. That's the problem. Turn it side, mine, turn it all over. Add it on back like yeah. Hey, do what you gotta do. You're gonna mess something up. You got the last step. You can't mess up. Just dump it all out down the sink. Good. Okay, so for those who are streaming, the rest is just clean up. So, unless you have questions, I'm gonna log out of Zoom, and the rest, everything else from this point forward that we're doing in here is just cleaning up. So does anybody have any questions?
No, thank you.
Nope, just let it drip. Anybody have any questions for me before we log out? No? All right. So what I'll do, I'm gonna post a recording once I get it, once I get it downloaded from the cloud, I'll post it to Blackboard along with the notes that we took today and, the values. I need to make sure I post those values too. So let me save this chat. I'll just take a screenshot of it. But I'll save those values too, and I'll post those to Blackboard too. And again, those of you who are streaming, you can pick which value you want to work with, and then we'll keep the samples consistent week by week. So we'll keep working with the same sample. So when we get the yield, the purity testing, the pH, all that stuff will be off that same sample. All right, any questions?
Yes, I have a quick question. So which boxes should we have done by next week?
The reagent table with the density, molecular weight, moles, and really that's it. Because you can't get the percent yield, you can't get theoretical, well, you can calculate theoretical yield, but you don't have to do that right now. But just really the reagent table, get that filled in, get the amounts put in that you use, and then that's it.
Okay, thank you.
All right. Other questions? All right, I'm gonna log out. We're gonna clean up, and then I'll see y'all again the next time we meet. And thank y'all for logging in. We got 35 people. We have more than that. We have 42 people logged in, but thank y'all for logging in, and just watch out for an announcement on Blackboard to let you know when all this stuff is uploaded.
Okay, thank you, Dr. Russell. You have
I'll
a
take
wonderful
care.
evening.
All right.